Thank you, Ryan, for talking about the future. I'm going to talk about the now. I am Nicole's boss, or manager, stepping out of the shadows. Let's see. So I'm going to talk a little bit about our journey in starting to serve AV1. Yesterday, Nicole talked about the ability to receive AV1 from contributors, and today I'm going to talk about how we're actually delivering AV1 to our viewers. So just a reminder from Nicole, not only do we receive a lot of different content in, we also push out content to a wide variety of devices. We kind of bucket them into what we call living room. These are connected TVs, desktop, and mobile. All right, we talk a lot about AV1. We talk about ISO bitrate, things like this. What does it mean? So I'm going to give you an example. I hope this comes out okay. That's a horrible image. This is 4K, high frame rate, coming in on H.264 at 10 megabits per second, which is a common bit rate for people streaming from their homes. Here's the same stream in AV1. You can suddenly see that tower in the background. Oh, it's not coming out that great. I'll show you on my laptop. You can see the grass, etc. And so there's a clear benefit to AV1, especially in network-constrained environments. So you have this trade-off when you're considering a new codec like this. You can either choose to basically keep ISO quality and have a reduced bit rate, or you can basically increase quality and keep your bit rates the same. This is a little bit of a trade-off. Although it's a money symbol on the egress because it certainly does impact your cost, it is also a quality of service play, since lower bit rates do result in lower rebuffer rates, etc. And then, of course, quality, like you saw in the last image. What we did is we basically set a target for improvements in our quality, and then we would take the rest in egress. So the challenges when you're going to do this is, first, AV1 is a much more complicated codec. So we need to make sure that we are transcoding in real time. I'll talk about what I mean by real time in a moment. Your complexity of your ABR ladder, the number of outputs you have to do naturally increases. And you have to you set some targets, you have to figure out how you're going to reach them. All right. So for those of you that don't know, YouTube built its own hardware encoder, and all live streams happen to be hardware encoded at YouTube. This internally, it is called Argos. The only reason I can tell you is because our VP inadvertently said it, so I can now call it Argos. These are video compute units. What I'm talking about is going to be, certainly locked into our hardware, but I think the strategies we take would apply to anybody using any sort of hardware encoding fleet. It requires a little bit of tuning, of course, to make sure that you're scheduling tasks and so forth. I'll dive into that right now. So the way that we model essentially work on one of these hardware encoders is we think about them as slots. These are the minimal sort of compute units that we have on a device, and basically the number of slots, the amount of RAM, et cetera, vary from generation to generation. But essentially, we then have an incoming job come in, an incoming stream come in, and we make a prediction on how many slots it's going to need, et cetera. Usually this is dictated by the complexity of the content. Is this 4K? Is this a 720 stream? Whatever. And then we go and schedule that work out in the fleet. Now, one thing if you're operating a large fleet in a data center is you're going to have to move tasks around. This could be because your prediction was bad. It could be because all of a sudden the workload. Like someone started, they were just talking, very low complexity, and then suddenly they're streaming like Doom Eternal or something like that. That's explosions everywhere. But the other thing you need to worry about is maintenance on your machines. For YouTube, we have live streams that last literally for years. I think the longest one I looked right now is like over 5 years old, running continuously for 5 years. We can't wait for that to drain to do maintenance. So we actually have to move jobs around in the data center. This gives us some advantages as well in terms of job scheduling. So what we can do is we make our prediction, we model very carefully, and then we essentially train an AI model to help us schedule work within the data center. It's essentially a very classic control system problem. All right, the other strategy is it could be that the jobs that you have, you're getting 4K, HDR, high complexity scene in, you may not be able to do all of that on one single chip. So what can you do to basically scale up and generate things? The first strategy we have is multi-chip. We do have two chips on a board, so being able to spread something across chips is beneficial for us. The other thing is we're outputting a bunch of different resolutions, so we can break up that multiple output transcodes into different jobs. So, like basically make H.264 and on one machine and the rest on another. And the final strategy is alternating groups. And here I'm going to talk a little bit about what I mean by real time. So real time does not mean I get 1 second of video for every real world second. What it means is I have a window, usually proportional to your buffer, and I have to, let's call that n seconds. And I need to create n seconds of video within n seconds. So by having alternating groups, if one particular transcode job starts falling behind, the next ones can maintain real time and you can quickly catch up. And that's your goal. All right, so now let's talk about the complexity of things coming out. Suppose I have a normal 1080 high frame rate stream. I have a ABR ladder for each one of the codecs. I compute both high frame rate and standard frame rate. I compute suddenly for all 3 codecs. Suddenly got 30 videos to output at the same time. When that jumps up to 4K HDR, this jumps up to 66 videos to output. So that doesn't just put load on your transcoder, that also puts load on what I think has been referred here as the origin server, or what we call publishing. So you have to think about all of that as you're going through and analyzing your system for adding another codec. We also support we have 3 latency classes: normal, low, and ultra low. Right now, AV1 is on normal and low, and we're in the process of rolling out ultra low. Excuse me. The thing is, this isn't under our control. This is something set by the user. So again, this creates a very complicated test matrix. My colleague Alexi, who's a co-author here, decided to have a child rather than come and speak to you all. He basically calls this a hypercube of testing. You have many, many different dimensions. So in order to do that, we collect and put together a very large test suite of content videos tagged by different types. So we have the ability to look at sports content, gaming content, talking heads content, etc. And then can go and try to tune profiles based on that. We also have a very robust AV experiment. There was a lovely talk yesterday talking about doing some testing And let me just say, I require 10x the number of samples before I believe the test results. But we're fortunate enough to have that amount of content. All right, so you've basically set up your original profiles. Everything is great. You run your test suite against it, and then you basically look at how I'm doing. This is called a quiver plot. Essentially, the dark things are where VP9 was, and then the arrows point to where AV1 is ending up. To look at this particular graph, you want to be up and to the left. Up and to the right is down and to the left is and if you're going down and to the right, you've got a bug. All right, you can see here there's a little bit of and why is there And the reason is, like, if the other thing to do here is, okay, that quadrant up and to the right, or up and to the left is mostly, I'm trying to do this backwards. The quadrant up and to the left is mostly normal video. The stuff that's in the like XY coordinate, the positive XY coordinate, is mostly high complexity. The stuff that is in the lower, the minus Z plus X quadrant is high entropy stuff. This is confetti. And what we found is that when we built rate control for AV1, it was doing a really good job of controlling rates. And so suddenly our confetti scenes and all of that were actually getting trimmed in bitrate, and so losing quality. And so now we had to play a bunch of games trying to gain some of that quality back. So, I mean, the easiest thing is just kick up your bitrate, convince everybody that that's okay. You can also look at strategies such as trying to capture some of the noise before you encode and add it back. In the end, after a lot of playing around and worrying about how important is confetti, and there's a Super Bowl coming up, confetti is kind of important in the Super Bowl. We finally basically settled on profiles that actually did hit our goal. So here I'm showing you VMAS scores, essentially AV1 over VP9, and we've actually exceeded our goals for AV1 quality. All right, where are we today? They didn't get the X's and the Z's put in, so I'll have to tell you those. Basically, over a third of our watch time is on Living Room is on AV1. In general, Living Room is doing very well in terms of AV1 adoption globally, and in certain markets, very, very well. Over 3/4 of the YouTube catalog weighted by watch time is available on AV1. There's thousands of live streams every day that are in AV1. And like I said, Living Room is doing really well. Desktop is nearly 100% can handle AV1. Our biggest opportunity, and I think Meta has talked about this before, is in mobile. We need to figure out what we're going to do for mobile devices that cannot do hardware decode. So our player team is looking really carefully at software decode and how can we do that within a particular envelope of power. All right, come on. Oops, there we go. All right, just if you're gonna do this, some suggestions, work closely with your partner teams. If you have people that are coding experts, talk to them. Hardware experts, talk to them. Monitor carefully. The big thing, and in this case, the leadership that was highly supportive is just back there, Des. Have your leadership support you and advocate for AV1. All right, thank you.
Thank you very much, Kirk. And a very quick question then in that case.
So don't tell me anything secret, but can the Argos cards, are they ready to be upgraded for AV2, or do you have to spin a new ASIC for that?
Our Argos cards right now, I'm sorry, what were you asking for about AV1 or?
AV2. AV2.
We have not burned hardware considering the codec just came out a few weeks, in this quarter, it's very hard to spin up hardware that supports it yet.
Thank you. Thank you, Kirk. Thanks very much for your presentation.